So our next speaker is Roger Shepherd from Chipless Limited, who is the founder and managing director. Roger joined InMOS in 1979 working on a transputer, Occam and many other things. He ran a processor design group within ST Microelectronics. In mid-2014 he set up his consulting company Chipless, which is a founder member of the IoT Security Foundation. Recently he was CTO of Lujam Security Limited. And the title of Roger's talk is Security, Verification and IoT Systems.
Right. Good afternoon. I'm Roger Shepherd from Chipless, and I'm going to talk about IoT systems and security. I was going to talk about verification as well, but I got a bit long. What I'm actually going to do is start by answering the question, what is the Internet of Things? And I'm going to look at some of the challenges in the Internet of Things, in engineering it, talk a bit about security in the Internet of Things, and how we might go about improving it. So what is the IoT? Well, it's not a market. It's not a technology. There may be markets for IoT systems, and IoT systems certainly use a lot of technologies. But it isn't a market, it isn't a technology. It's a concept, and it's the evolution of computing and the internet for this era. It has its roots in things like ubiquitous computing, which was an idea spread by Xerox PARC back in the late 1980s. Interestingly, they contrast it with the then very new and trendy virtual reality. But the key thing is that it's about computing in the real world. It's also the third wave of the internet, the first wave being mainframes and terminals, the second wave being PCs. And this is from Bruce Schneier, the well-known cryptographer, written in January 2001, so quite a long time ago now. And this comes from the preface to Ross Anderson's book on computer security. And he says, the third wave, starting now, will see the connection of all sorts of devices that are currently in proprietary networks, standalone and non-computerized. Within a few years, we'll see many of the world's refrigerators, heart monitors, bus and train ticket dispensers, burglar alarms and electricity meters talking IP. So it's about proprietary networks moving to IP networks, things that were standalone becoming connected, and non-computerized things becoming computerized. So what challenges do we get from the IoT? Sorry, I suddenly saw a thermometer on my screen. So Mark Weisner of Xerox PARC said, ubiquitous computing is a very difficult integration of human factors, computer science, engineering and social sciences. And I'll talk about the engineering issues and some of the computer science issues. But this integration and the whole scale of the IoT creates many problems. So in the engineering challenges, we have a number of goals to be met. We want our systems to be reliable. We want them to have some sort of longevity. If I buy a fridge, I expect it to last 10 years, not 10 months. We expect the systems to be safe, and this is an issue where we have cyber physical systems being built, and we want them to be secure. We want them to look after our data and our privacy. The IoT presents challenges in the forms of some of the constraints we have to work under. Very often there can be severe power and energy limitations on a system that, for example, could make it difficult to deploy standard cryptographic techniques or limit our ability to transmit a lot of data. We built the IoT on top of an unstable infrastructure, and I'm not just talking about the IP connectivity being unstable. I'm talking about things like the higher levels, the APIs that we build systems on top of, changing from month to month. And of course, this is challenging if you're trying to build a system that's going to work for 10 years. We have a challenge given by physical access. IoT devices can often be picked up, taken to pieces, which gives us issues with security, reliability, safety, etc. We also often are faced with very limited interfaces to the devices. The devices are small, they have no means of entering data easily. We also have a lot of technologies in use. Networking, obviously, it's the Internet of Things, so networking. We're often building distributed computing systems, and these are, whatever anyone says, difficult to build reliably. We have to manage connectivity, in particular wireless connectivity, which some of us think fundamentally doesn't work. And of course, these systems contain lots of software, and we know how easy it is to build big, reliable, secure, safe software systems. Because of a couple of things, because of the software presence and the need to fix its bugs and the security holes in it, and the fact we have a very very unstable infrastructure, we have to look at updating software in the field. And then there's some other problems that we face. We have to look after identity and credential management in a lot of the big systems, a known hard problem. We have an awkward supply chain going from silicon IP, chips, electronics, software of various flavors, network systems, cloud providers. And the business models aren't always easy. And there's a lack of cookbooks. You can't just pick up an instruction manual that tells you how to build a reliable, long-lived, secure, safe IoT system. So, I should ask the question, are these challenges being met? And I think the answer is they're not. A couple of examples. Here's one recent one. A failure in Amazon's data center in Virginia left people unable to use their IoT devices such as remote TV remotes, connected light bulbs, and even garage doors. Even though it was in Virginia, the impact was felt worldwide. I personally think the idea of building a system where a failure in a data center on another continent means you can't switch on your light bulb here in Reading is crazy. Another example, a well-known Samsung fridge that has the great idea of being able to display a calendar on it, wasn't kept up to date. Amazon changed the APIs for Google Calendar, and you had to show your calendar by using blue tack and a sheet of paper. Security. Today, I think everyone is aware there's massive IoT insecurity. This is the case. Nest security cameras can be knocked out with a simple Bluetooth attack. Mirai botnet, based on compromised CCTV cameras and digital video recorders that were exposed to the internet with things like username, admin, password, created a large botnet that you could rent and caused a massive outage on the East Coast, well, throughout the States. Most recently, this network dishwasher having a directory traversal bug, it just goes on and on and on. I want to go through one example in some depth just to illustrate the sources of some of the problems and look at how bad the situation can be. This example is due to Ken Monroe of Pentest Partners, who did the penetration test on this iKettle. This device is a network-connected kettle. The idea, it's really useful because you can sit in bed with your phone and switch the kettle on. So when you go downstairs, you save yourself a minute. because the kettle's already boiled. Now, one of the things you have to do with this kettle is join it to the Wi-Fi network. It comes with just one lead. It doesn't have an Ethernet lead, so it's wireless connected. To join a Wi-Fi network, you need the SSID and the encryption key. Great. But we have this problem of a limited HMI. There's only a few little buttons here. It's not quite as bad as an Amazon Dash button, which is, as it says, a button. How do you enter? How do you enter your credentials on that? Oh, the answer is, in the case of the iKettle, you use a phone. The kettle implements a Wi-Fi access point. So you download and run the iKettle app on your phone. You connect your phone to the home network, and now the phone knows the name of your home network. You then connect the phone to the iKettle network, and you can talk to the access point in the iKettle. And you enter the password for the home network. And the app talks to the kettle, tells the kettle the SSID and password, and you can now join the home network. Great. What could possibly go wrong? Well, I had in mind maybe a hacker could switch on my kettle. But actually, it's worse than that. You can compromise the home network because of insecurities. And the way you do it is you create a high-strength so-called evil twin Wi-Fi network with the same SSID as the home network. You throw the iKettle off the home network using a deauthorization attack. Now, if you don't know how to do that, it's all right, because you can download some software from the internet to do that for you. And the kettle, having been thrown off the network, will try and rejoin, but it will join the evil twin network instead. Ah, great. Now I can connect to the iKettle's telnet service. And I do have to authenticate, but actually I've worked out that the pin is 000000. I'm in. I type in AT key, and out comes the WPA pre-shared key for my home network. I'm into the home network. The hacker has access to the home network. And probe round, you didn't change the default password on your router. Oh dear. So just to go through this, there's a number of weaknesses, bugs, faults, but people seem to say weaknesses. They're faults. They shouldn't have happened. In the iKettle Android app, it sets the telnet default pin to 6 zeros. The iOS app actually randomizes the pin. Another problem is the default pin is actually visible if you reverse engineer the app. Now this device is the module that gives the Wi-Fi access point, the Wi-Fi capability of the kettle. It's that device that said it's a 6-digit pin, and 6 digits can be forced in 4 hours using software you've downloaded from the internet. The network's authenticated by SSID only. It'll attach to a network with the same SSID but no password, and you get the plain text password back. Now, you might say, well, that all seems very complicated. How could somebody think of that? But there's a lot of information available. You can take an iKettle to pieces and see that it uses that particular Wi-Fi module. You can find the manual for the Wi-Fi module on the internet. You can reverse engineer the iKettle Android app. And then you can use the internet to search for places that have got iKettles. And in case that's rather difficult, there are courses to help you out. There's the Udemy Ethical Hacking course, and all you need to do is not take the ethics module. So here we saw the fact there was a limited HMI which didn't allow direct entry meant that we had to use a more complicated solution. There were security weaknesses in that solution, and the home network can be exposed. Now I must say I have a certain sympathy, because although they should have got this right, they bought this Wi-Fi module, and you might think, I buy something, it should work. So it's a supply chain problem as well. Now, what can we do to improve security? I believe we won't get security without there being a far greater awareness of the importance of security for customers and suppliers. At the moment, I don't think customers are asking for it enough, so why would somebody invest in providing it? So it has to go all through the value chain. We need more knowledge, and we need the components that can be used to build these systems. On awareness and knowledge, there's a lot happening. There are organizations like the IoT Security Foundation, the GSMA, who are putting out information about how to do things and creating awareness. This is good. GSMA have recently put out 200 pages of information about what you should be doing. In terms of components, I've taken cryptography because it is a key part of providing security. There's a number of problems that we have to overcome: software mishandling secret keys, power performance issues, software leaking information through being badly implemented. So we want things like key stores, crypto engines, secure crypto software, true random number generators, and we want to be able to easily use this from standard software. And we are slowly getting there. So, for example, this is one of ARM's offerings. It includes asymmetric and asymmetric cryptography, true random number generator, etc. And ARM's licensees, Atmel, are using this for this MPU, advanced security functions, and it lists here the hardware cryptography. Elsewhere in the supply chain, if I go to the Atmel partner website and look up the people who are supporting that device, unfortunately, of the 30 partners, only 3 of them mention security anywhere in what they're doing. So, in summary, IoT system quality can be truly dreadful. Security can be very bad, and reliability, longevity, etc. It is hard to secure the IoT, but existing best practice avoids common problems, guidance is available, and the availability of security enabling components is improving, but still has some way to go. So thank you for your attention.
Are there any questions for Roger?
Roger, Jeremy Bennett from Embercosm. Can I just check something? On the iKettle attack, the one mitigation is you do need some physical proximity for that one to set up the actual attacks. You need to set up a fake network. So in one sense, it's not quite the very worst thing out there in that you can't attack from the other side of the world.
No, this is true. I mean, but we can find other devices where there are bad attacks. I mean, I chose that one because it's about the right size to go in a presentation of this, and it illustrates so many basic problems that really people should not be getting wrong.
You don't have to be there, you just hack your neighbour's router. Most of them are readily available.
Well, it's not clear that the neighbour's router would create a large enough, a strong enough signal to be the evil twin network. You know, you're better sitting outside with a high gain antenna.
Any other questions for Roger? Okay, thank you very much, Roger.